Ever watched a drone just hang in the air, totally still, even when the wind is blowing? Or thought about how a car can actually drive itself? Well, it's not magic. It's the science of automatics and robotics. And in this explainer, we are going to pull back the curtain and show you exactly how it all works.
So, let's start with that drone. Just picture it. It's hovering, locked in place like it's frozen in midair, while a breeze is picking up around it. I mean, how is that even possible? Well, it's a really brilliant piece of engineering, and the answer to that question reveals this invisible force that, believe it or not, runs a huge part of our modern world.
And that answer? It's a field called automatic control. You can think of it as the invisible nervous system behind so many of the machines we rely on. It's the silent, constant decision-making that keeps things running just right. And it's the very first building block we're going to dive into.
All right, so before we can even get to the cool-looking physical robots, we have to understand the brains behind the whole operation. This is the secret of control. It's where machines learn to act all on their own, without a human telling them what to do every single second.
You see, at its very core, automation isn't just about making stuff move. It's about controlling a system so it behaves exactly the way you want it to. And here's the most crucial part. It does this all without human intervention. Honestly, that's the entire goal right there.
Now, to make that happen, systems are basically built in two main ways. On the one hand, you've got an open-loop system. Think of this like a simple light switch. You give it a command, you flip it on, and it just runs. It has no clue if the room is already bright or if it's pitch black. But then on the other hand, you have a closed-loop system. And this is where things get smart. It uses a sensor to get feedback. So an industrial oven doesn't just get hot. Its regulator is constantly measuring the temperature and tweaking the heating element to keep it exactly at the right degree. That feedback loop, that's the absolute key to all advanced control. And that basic idea of feedback? Well, it can get incredibly sophisticated. Our drone, for instance, is using something called PID control. It's constantly measuring these tiny errors, we're talking fractions of an inch off course, and correcting them hundreds of times a second. You can think of it like a super fast, non-stop balancing act. Other systems use what's called adaptive control, which lets a robot on an assembly line adjust its grip for a huge heavy box 1 second and then a tiny delicate part the next, all without needing to be reprogrammed. These are the tools that give machines their incredible precision. Okay, so we've got the brains, that's the control system. Now it's time to give it a body. And this is where we step into the amazing world of robotics, the physical machines that actually use these control systems to reach out and interact with the world around them.
Right, so robotics is where those control systems get to, get their hands dirty. It's this incredible mashup of mechanics, electronics, and computing, and they all have one goal: create a physical machine that can perform tasks all by itself. So let's meet a few of these robots.
First up, you've got the workhorses of the modern world, industrial robots. These are typically those massive, powerful, and super precise robotic arms you'd see in, say, a car factory. They're doing things like welding and painting with a kind of speed and accuracy that's just, well, superhuman. We're talking about giants in the industry like Fanuc or Coop. Next, we have the robots that don't just stay in one place. Mobile robots are all about getting out there and navigating the world. This category is huge. It includes everything from that little robot vacuum cleaning your floor to the incredibly complex systems in a Tesla on autopilot, and of course our hovering drone from the beginning.
And then you have the robots that are built to look like us. But why? Why make them look like people? Well, humanoid robots like Asimo or Sophia are designed this way so they can operate in a world that was built for humans. So they can climb stairs, open doors, and interact with us in a way that feels a little more natural.
One of the newest and most exciting trends is the cobot, which is short for collaborative robot. For decades, those big industrial robots had to be kept inside cages for safety. But cobots? They're totally different. They are designed with advanced sensors to work right next to people, almost like a powerful assistant on a shared project. So, let's recap. We have the brains, which is automatic control, and we have the body, which is robotics. But to really unlock their true potential, we need to add the final and most powerful component. We need to give these robots a mind. And that, right there, is where artificial intelligence comes into the picture.
So how does AI actually create intelligence in a machine? We can really break it down into 3 simple steps. First, the robot has to perceive its environment. Then, it needs to understand its location and navigate through that space. And finally, based on all that data it's gathered, it has to decide what to do next. Perceive, navigate, and decide. That's the loop.
To do all this,
Engineers use this really powerful AI toolkit. Computer vision literally gives the robot eyes, letting it see and identify objects. Then there's something called SLAM. It stands for simultaneous localization and mapping. It's like giving the robot an inner ear and a map maker all in one, so it always knows where it is, even if it's in a brand new place. And powering all of this are neural networks. You can think of these as the robot's learning center, allowing it to get better and better at tasks over time, just like we do.
Okay, and this is where it gets truly transformative. When you combine an intelligent control system, an advanced robotic body, and an AI mind, you don't just get a machine anymore, you get an autonomous agent. These three building blocks are coming together to create our automated future, and it's happening right now.
And this isn't science fiction. In what people are calling Industry 4.0, smart factories are automating really complex production lines. In medicine, the Da Vinci surgical system lets surgeons perform operations with just incredible precision. In space, the Perseverance rover is exploring the surface of Mars all by itself, millions and millions of miles away from us. And right here on our roads, companies like Tesla and Waymo are pushing the absolute boundaries of what's possible with autonomous transport.
All of this progress, from the control systems that act as brains to the AI that gives them a mind, it's undeniable. And it leads us to what is maybe the most important question of our time. As automation continues to advance and get better and better, what is it that we as humans will do best?